Lesson 75 is about the slope-intercept method for determining the equation of a line. Now, up to now, you've been graphing lines based on an equation of a line that's been given to you, and it may have a form like this, or it may have a form like this, or something else. In all of them, though, there's always an x variable, a y variable, and then a constant. Now, there is what's called a standard form for an equation of a line, and that's when y is first and then equal to m, some constant, times x plus this other constant value. So y equals the coefficient of x, which is m, and then plus a constant. Now, if you recall, when you've been graphing equations of a line, you always rearrange them, if you need to get them in this form where you have y on the left by itself and then x and its coefficient plus the constant on the right side of the equal sign. Then you set up an xy table and you pick just 3 convenient values of x and then solve for y for each of those values of x. Then you plot those ordered pairs on an xy coordinate system and you draw your line through those points. What I'm going to show you in this lesson is a shortcut to doing the xy table and then plotting the points. First, though, let's understand this by solving the equation for a line the old way. Then we'll talk about the new way. Look at this equation of a line that I have. Y equals 2x plus 1. That's in the standard form where y is first, then the coefficient times x plus a constant. So let's go ahead and make ourselves an xy table. And let's just choose 3 convenient values for x. Let's just use -1, 0, and +1. And so we'll substitute those in to solve for y. When x is -1, we'd have 2 times -1, which is -2, plus 1, which is -1. And then when x is 0, y is +1. When x is 1, y will be equal to 3. So we have 3 ordered pairs there now. Now let's go ahead and make an xy axis or Cartesian coordinate system, however you want to describe it. Put an x here and a y here, and then put some tick marks evenly spaced. Now let's go ahead and plot our 3 ordered pairs there. The first one is to the left 1 and down 1, so we'd put a point here. The next one is to the left or right none because it's 0, and then up 1, so right there. And then the third one is to the right 1 and up 3, so right about there. Then we just draw our line through that, and there's the graph of that line. Now, notice some important things about this line. Notice where it intersects the y-axis. It intersects the y-axis when y is equal to 1. And that's the same thing as the constant in that equation, y equals 2x plus 1. So in our standard form, b, that's considered the y-intercept. That's what it's called. That value, as long as you have the equation of a line in standard form, that constant term will always tell you where the line crosses the y-axis. The steepness of the line, or its slant, that's determined by the coefficient of x. And we call that, we don't call it the slant, we call it the slope. And so that's the name given to that value m, is the slope. Now the slope, what it does is it tells you how that line changes with respect to x and y. Watch, for example, if I start at the y-intercept, I'm going to put a red dot there. If I go to the right 1 and up 2, I end up hitting the line again. If I go to the right 1 and up 2 again, I end up hitting the line. Likewise, if I go to the left, if I start back at the y-intercept and go to the left 1, and go down 2, I end up hitting the line again, and I can repeat that again. Left 1, down 2, and I hit the line. So hopefully you're picking up that relationship there, that the slope, it's equal to the ratio of the change in the y direction over the change in the x direction. On those little drawings that I did, every time I moved to the right 1 or I changed my x value 1, I had to change my y value 2 to get back to the line. And so that means a change in y of 2 over a change in x of 1. And that is equal to 2, right? That's the coefficient in front of the x term for this equation of a line. Understanding the slope is a really, really important thing. You will use this all the way up through calculus and beyond. Now think about this too. When I've started back at the y-intercept and I moved to the left 1 and down 2 to get back to the line, I was moving negative values, right? So I moved to the left 1, that was negative 1. I moved down 2, that was negative 2. That still equals a positive 2, right? So the slope, that tells me that the slope is a positive 2. Now something you can always check when you look at that coefficient of x or the slope, if it's a positive number, the line will slope uphill like that if you're looking at it from left to right. That's called a positive slope. If it's a negative in front, or a negative coefficient in front of the x, the slope is negative for that line. It goes downhill if you're looking at it from left to right. So now that we know what the slope and the y-intercept are, let's go ahead and try to graph a line just using the slope-intercept method. So look at practice problem A there, y equals minus x plus 4. So let's just go ahead and write down what the y-intercept is. I'll just say y dash int, and we know that that's this constant, and so we say the y-intercept is a positive 4. And the slope, that's always the coefficient of x. So that includes the sign in front of it. So since it's minus x, that means the slope is minus 1. And so if we want to think about that a little bit more, that just means our change in y. Now watch, I'm going to use a triangle. That's also called a delta symbol. That delta symbol means change in. So that's just an abbreviation for change in. So change in y over change in x. If we want to rewrite this as a fraction, it's minus 1 over 1. Now since it's a negative number, it could also be 1 over negative 1. It doesn't matter. Either way, we can think about it. So what that means is that every time we move to the right 1, we would move down 1 as well. And that gets us back to our line. Let's go ahead and graph this line on that Cartesian system that we have to the left. So the first thing that you do when you're graphing these lines is you just find the y-intercept on there. And so let's just put a point at 4. So we'll start there. Now, what we want to do is go ahead and look at our change in y over change in x. Down 1, because it's a negative 1, to the right 1. And so we go down 1 to the right 1, make a point. Down 1 to the right 1, make a point. Down 1 to the right 1, make a point. We have 4 points now. That's plenty to make our line. And so there's our line right there. Now those little triangles that I'm drawing to the sides there to show down and to the right, you don't really need those on the line because I'm just doing that to help you show the direction that I'm going. Just like those red triangles that I drew on the blue line, the first one that we did. Those are just to show you where we're going with our points and how to figure out where the slope goes. You really just want to erase those, or maybe do those lightly with a pencil, and then you can go back and erase them. And there's the equation for the line graphed on a Cartesian coordinate system. Now if you get stuck using the slope-intercept method, just go back and make your xy table and graph it that way. But try to understand the slope-intercept method and apply that to what you know about the xy table method. Let's go ahead and do some more problems where we're going to graph the line using the slope-intercept method. Now I've rewritten the standard form up there, y equals mx plus b. Remember, b means the y-intercept. Whatever the value of b is, that's where the line will cross the y-axis. And then the slope is just equal to the change in y over the change in x. Sometimes it's also called the rise over the run. So that might help you think about the slope a little bit more. Rise means vertical, run means horizontal. Let's go ahead and make a Cartesian coordinate system. Make a nice big one here. And then we'll go ahead and graph those lines. Okay, so the first one, y equals 1/2 x minus 2. Remember, we always start with our y-intercept, and let's just go ahead and write down what it is. Let's just say y-intercept, int period, that's going to equal -2. That's where this line will cross the y-axis. And then the 1/2, that tells us that's the slope, and so we'll just say delta y over delta x is equal to 1/2. I like to write delta y over delta x instead of m because that helps me remember that it's a fraction and I have to move a y direction as well as an x direction. So let's go ahead and start. We know what our y-intercept is, -2, so let's put a point at -2. Our slope is +1 over +2. So that means we move up 1 and to the right 2. And I'm just going to put a point there. I'm not going to show the triangle shape that goes like going up and to the right. I'm not going to show the path. And then let's do one more so we can make our line good. Up 1 to the right 2 would be right there. Now let's go ahead and draw the line through those points. And there we have our line. Now one thing to think about here, that line continues on. It's a line, so it has to continue on infinitely in both directions, to the right and to the left. So one thing we could think about here, y equals +1 over +2. It also equals -1 over -2, right? Because that's the same thing as +1/2. So we could start at the y-intercept, go down 1 to the left 2, and we should hit the line. Go down 1 again to the left 2, and we should hit the line, and we do. So you can think of a slope that way as well. You can change the sign of the numerator and denominator, and you won't change how the value of the slope. You'll just be able to think about how to plot your points a little bit better. Let's go on to practice problem C. Y equals -1/3 x plus 3. So we have a y-intercept of 3, +3, and then the slope, delta y over delta x, is equal to -1/3. So I'm just going to put the negative sign in the numerator. -1/3. We could put it in the denominator. It doesn't matter. We could have 1 over -3 or -1/3. It doesn't matter which way we do it. So that's our slope. And so let's go ahead and graph this. You always start at the y-intercept. And so we go to that point and make a dot there at +3. The slope is a -1/3. That negative sign tells us it's going to go downhill if we look at it from left to right. So if our line is not downhill, we're doing something wrong. Go down 1 to the right 3 and make a point. Down 1 and to the right 3 again. And I don't really have a third mark on the graph. I'll just go ahead and put one right there. It'd be about right in here. Draw the line through those points. And you see that it does slope downhill from left to right. Let's do one more. Look at D. Y equals x. Don't get confused on this. Look at your standard form. Y equals m times x plus b. Well, if there's no constant, then it must be 0. So we just say y-intercept equals 0. And if x is by itself, that means that its slope is 1. So delta y over delta x is equal to positive 1 over positive 1. Always, when your slope, or m, is a whole number, just write it over 1 to make it look like a fraction. So let's go ahead and start graphing our line. Our y-intercept is 0, so that means we start at 0 right here. Our slope is 1 over 1, so we go up 1 to the right 1, up 1 to the right 1. Now we could also go down 1 and to the left 1 from the y-intercept. Down 1 to the left 1 again. And so we can see our line developing there, so let's just go ahead and connect the dots basically, and there's the line for equation D. The slope was positive, so it's uphill from left to right. That's what we expected it to be. So some things to remember when you're doing the slope-intercept method for graphing a line. First, determine what your y-intercept is and what your slope is. Think of the slope as a fraction. Then go over to your Cartesian coordinate system, put a point at the y-intercept. You always start at the y-intercept. Then look at your slope and just move appropriately. Move your y distance, then your x distance. Y distance, then your x distance. Put a point each time after you've moved the y distance, then the x distance. Now that we're finished, I'm going to go ahead and put back on the path that follows when you make the slope and go to the next point. So let's just use example B, the red line there. Start at the -2, the y-intercept, and the slope is 1/2. So that means we go up 1 to the right 2, up 1 to the right 2. Or from the y-intercept we can go down 1 and to the left 2. And see how it makes a little triangle each time you do that path? That's an important thing to remember. It makes a little right triangle. All I'm doing there is I just want to show you the path that you follow when you make the slope or figure out how to plot your next point relative to the y-intercept. You just do them in order. You move your y distance, then you move your x distance. Stop, make a point. Move your y distance, then from that spot move your x distance. Stop, make a point. Next, we're going to do the reverse of what we just did. I'll give you an equation of a line. I'll give you the line on the Cartesian coordinate system. You have to figure out the equation of a line. Now on these problems, I've given you some lines that are on Cartesian graphs. You need to take those and turn them into an equation of a line. So let's just look at E, and let's just think about our standard form for an equation of a line. Think about that first. And why don't we just go ahead and write that down? Y equals mx plus b. That'll help us think about what to do. And we know that in that standard form for an equation of a line, m is the slope of that line, b is the y-intercept. B is the easiest thing to find, so let's just go ahead and do that first. And we see that line intersects the y-axis at positive 1. So we'll say y is equal to mx plus 1. So basically we're halfway done with this problem of finding the equation of a line. We know what the y-intercept is, we just need to figure out the slope. That's a little bit trickier than figuring out the y-intercept. So let's go over to the line and let's put our pencil or pen right at that point of the y-intercept. And let's try to figure out what the slope is. If we moved up 2, we'd have to move over 1, 2, 3, 4 to hit the line again. So let's just think about that. We went a change in y of 2 and a change in x of 4. So our slope, let's just write it to the side here. M is equal to a change in y of 2 over a change in x of 4. That's 2 over 4 or 1 over 2. So the slope is 1/2, and so we write y equals 1/2 x plus 1. That's our equation of a line for that particular line that's been graphed. Now, since we had to reduce that fraction, that means that I didn't find the simplest way of figuring out the slope. Really, I could have just moved up 1 and over 2, like this. If you go back over there, move up 1 to the right 2, and see we hit the line there. So that's okay though. All we have to do is just reduce the fraction to its simplest form. It doesn't matter if we had moved up 3 and to the right 6. In this case, it was moving up 1 and to the right 2. That's what got us the slope. But since we moved up 2 and to the right 4 on the first try, we just had to simplify that fraction. Now look at f. That's just a horizontal line through the y-axis at -4. So if you remember how to do equations of vertical and horizontal lines, you just say whatever they're equal to, whatever they cross the axis at, that's the equation, y equals -4. And so that's all you do for f. Now on G, G is that red line moving uphill from left to right, so we know it has a positive slope. So first, let's figure out the y-intercept, and we see that it intersects or intercepts the y-axis down there at -3. And so that's the y-intercept. We can go ahead and write y equals m times x minus 3. Now we need to figure out the slope. Slope is change in y over change in x. And when we do the slope, it's always some ratio of integers. It's not going to be like 1 over 1.7 or something like that. It'll always be a ratio of integers. That's how these problems are set up. Now you could have a slope like that, but you're just learning how to figure out the slope, so they're trying to keep it simple and so that you just have to work with whole numbers on these problems. So let's go ahead and figure out the slope for this line. Start at the y-intercept. Now if we move up 1 and over, we don't get to a whole number spot. We didn't move like one whole tick mark over. If we move up 2 and over, we still don't quite move a whole tick mark to the right. If we move up 3, we move over exactly 1. And so there's our slope, 3 over 1. And so let's go ahead and write that in to our equation of a line. And so y is equal to 3 over 1. That's our change in y over change in x, or just a positive 3, times x minus 3. Now we know that slope is positive because it's going uphill from left to right. And so that's correct to write it as a positive 3. Now our last line there, line H, it has a negative slope to it, so we know, or a downhill slope, so we know it's going to be a negative value for the slope. Let's just go ahead and calculate the y-intercept first, and we'll write down y equals mx. It intercepts the y-axis at a positive 3, so we'll say y equals mx plus 3. Now let's go over to the line, starting at the y-intercept, and figure out what the slope is. So we'll put a dot right there at the y-intercept. Let's go down 1, and to the right 1, 2. So there's the slope, is negative 1/2. We went down 1, so we moved in a negative direction. Then we went to the right, positive 2. So the slope is negative 1/2. And we say y equals negative 1/2 times x plus 3. And so that's correct that that's a negative slope because we can look at it and see it's downhill from left to right. That we write it as a negative number. If you need to go back over this lesson, I would encourage you to do that. It's real important to understand the slope-intercept method and how to use that to graph a line, and then also how to use it to create an equation for a line that's already graphed. Okay, well that's all for lesson 75.